There's a line of data there. And it starts with line 22 and ends with 7b58. So we're at Separatrix Accelerating Structures Part 1 by G. Wow Seti. There's a second video that goes with this as well. Okay, there's the alien radio signal there. And this is the transmission of electromagnetic waves, keyword research in the WOW data. Okay. It's from Separatrix splitting. There's a line of data there from 7b57. Higgs field beam bunching signals formula. UFO 5G Wow Seti. That's a long video. It's got a lot of really cool stuff in it though, so you want to take a look at it. This is a keyword that I got from that particular formula, so I looked it up and I found all sorts of goodies about it. So there's quite a few videos about the Separatrix splitting. It's got a lot of really good data in it. So accelerating structures. So modern accelerating structures operate on principles similar to those described in this section. However, since electrons of a few hundred MeV are already highly relativistic, it is not necessary to vary the length of the drift spaces within a structure, as is usually done with the Alvarez structure. As such, it is possible to shorten the drift space a great deal so that the electron bunches spend more time within the accelerating field. Such a structure is called a standing wave structure. An example of a standing wave structure for NLC is shown in this figure. I should have named this standing wave structure instead of Separatrix. Okay. Oh well. This is a 15-cell NLC copper standing wave structure installed at the NLCTA. I don't know what that stands for. I should have looked it up. The two waveguides feed the RF power into the structure through the centrally mounted input couplers. Okay. The RF is introduced into the structure in such a way with the correct mode that a standing wave is set up along the length of the structure with nodes at the interfaces between the cavities or cells. The standing wave consists of a longitudinal electric field with no longitudinal magnetic field, a transverse magnetic or TM mode. This provides the necessary accelerating force in the form of longitudinal field, E field. Such a structure is usually driven in the P mode with E field configuration shown in the figure. The size of cells is designed to be resonant at the accelerating frequency. The structure uses a single pair of centrally mounted RF input couplers to deliver power into the structure. This input power is used to sustain the accelerating field within the structure and deposit power to the beam. Any unused power either gets absorbed by the structure, hence the copper cooling pipes mounted on the outside of the structure, or escapes down the beam pipe. Now I'm thinking, you've got unused power. You don't want to waste that. So we'll probably find something to do with that unused power. Okay? Escapes down the beam pipe. So an NLC traveling wave structure installed. The structure has 4 RF couplers, 2 input and 2 output. A development of the standing wave structure used almost exclusively in linear accelerators is the traveling wave structure. An NLC traveling wave structure is shown in this figure. That's the traveling wave one. Interesting. Okay, so the method of acceleration is similar to the standing wave structure, and the time-varying longitudinal E field is used to accelerate the beam as it passes through the cavity. However, instead of setting up a fixed standing wave forming nodes of oscillation at the cell boundaries and the antinodes in the centers of each cell, the sinusoidal E field is now launched from the front of the structure and runs along in synchronization with the beam. As such, the maxima and minima of the accelerating field are no longer fixed standing, but move with the beam travel, providing a continuous acceleration. Instead of so you could use that in the tevatron ring structure, right? With the protons. Instead of behaving as a resonant cavity, the structure now behaves as a waveguide, allowing RF power to travel along its length. So then you would use that to create your frequency for the communications device. Waveguides are essentially tubes with either a rectangular or circular cross-section that allows the transmission of electromagnetic waves and hence RF power with virtually no power loss. The energy is stored and transmitted in the form of resonant electric and magnetic fields within the structure. The available modes of oscillation within the waveguides for a particular frequency are fixed by the transverse dimensions of the waveguide. The minimum frequency sustainable within a waveguide is referred to as the cutoff frequency. Keywords are separatrix splitting from this accelerating structures, and it's going to continue, of course, in the next video. Thanks for watching.